Hello there and welcome to the Sleepy Universe. Tonight we follow one long night around the world, watching how animals actually sleep from dusk to first light. Right now, somewhere on Earth, a mother dolphin is swimming slowly in a circle, only one half of her brain asleep, one eye closed, the other watching for danger. Sleep, it turns out, is one of the most stubbornly universal habits in the animal kingdom, appearing in some recognizable form in nearly every creature scientists have thought to study carefully, from mammals and birds down through reptiles, fish, and even insects whose nervous systems look nothing at all like our own. Researchers define it less by outward stillness, which can be misleading, and more by a specific set of measurable signals, a raised threshold for waking, a particular posture returned to again and again, and a kind of rebound hunger for sleep after a period of being deprived of it. Roughly 2 out of every 3 mammal species researchers have examined show these signals in fairly familiar ways, though the amount of sleep any one animal needs varies enormously from species to species, shaped by diet, body size, and how exposed that animal is to predators while its guard is down. Tonight, as the sun eases toward the horizon in one place after another, this ancient pattern begins quietly asserting itself across an entire hemisphere at once. Somewhere beneath that darkening sky, one more animal has already gone still, following a habit shared by nearly every creature alive. Underneath nearly all of this lies a small cluster of cells, no larger than a grain of rice, sitting deep inside the brain of most vertebrates and known to scientists as the supraplasmatic nucleus, a name far grander than the structure itself, but entirely fitting for the job it does, quietly keeping time. This tiny internal clock listens for light, mostly through the eyes, and uses that information to run a roughly 24-hour cycle that shapes when an animal feels alert and when it feels the gentle, mounting pull toward rest. Even creatures kept in constant darkness in laboratory settings, cut off from any outside cue at all, will keep drifting through something close to their normal daily rhythm for a surprisingly long stretch of time, proof that the clock runs mostly on its own. As dusk settles now over forests, coastlines, and open plains in turn, this same ancient internal clock is quietly nudging one species after another toward the same soft, gathering pull. This built-in clock is why many animals kept away from any natural light cue at all will still, remarkably, keep drifting through something resembling their normal daily rhythm. In laboratories and burrows alike, that same small cluster of cells keeps its patient count, entirely indifferent to whether anyone is watching. As daylight fades, a hormone called melatonin begins rising steadily in the bloodstream of countless animals, released by a small gland deep in the brain, once the eyes register that darkness is genuinely falling rather than simply passing behind a cloud. In humans and in a great many other vertebrates alike, this rising tide of melatonin does not force sleep outright so much as it quietly signals that the appropriate window for sleep has now opened, lowering body temperature slightly and easing the whole system toward a state where rest becomes easier to slip into. Some animals produce melatonin on a schedule tied closely to the seasons as well, so that the changing length of nights across a year subtly reshapes how much they sleep and when, a slow calendar written in hormones rather than ink. Tonight, in body after body, that same quiet chemical tide is beginning to rise, unseen, unhurried, and entirely dependable. In this way, melatonin functions less like a switch and more like a slow, dependable dimmer, easing an entire body gradually toward rest rather than forcing anything abruptly. We can let that slow chemical tide rise on its own now, unhurried, and simply listen for whatever comes next. Sleep needs across the animal kingdom vary so widely that placing them side by side can feel almost implausible, with some bats and opossums content with something close to 20 hours of rest in a single day, while a giraffe out on the open savanna, ever watchful for lions, may make do with well under 5. Body size plays some role in this pattern, since smaller animals typically burn energy faster and seem to need more recovery time relative to their size. But exposure to danger matters just as much, if not more, tipping the balance firmly toward wakefulness for grazing animals living in open, predator-rich country. Diet matters too, since animals eating nutrient-poor food, leaves in particular, often need long stretches of stillness simply to process what little energy that food provides. Tonight, across a single time zone, a bat may already be settled into hour after hour of sleep, while a grazing herd nearby has barely paused at all. Closely related species living in different habitats can show strikingly different sleep totals, shaped by local pressures. A bat somewhere is already hours into its rest tonight, while a nearby herd has barely closed its eyes at all. As the sun drops low over open grassland and woodland alike, many birds begin gathering into loose, restless groups, drawn by some shared instinct toward the particular safety that numbers provide once darkness starts to fall, and eyesight becomes less reliable for spotting danger. European starlings offer one of the most striking versions of this evening ritual, swirling together into vast, shifting clouds known as murmurations before finally pouring down, all at once, into a chosen stand of trees or a reed bed for the night. Scientists studying these gatherings believe the shifting, swooping shape of the flock itself may help confuse approaching hawks, each bird reacting instantly to its nearest neighbors rather than following any single leader through the sky. Once settled, thousands of birds may pack closely together on the same branches, sharing warmth through the coldest hours before the whole shimmering cloud lifts again at first light. Researchers who study these evening gatherings have noted that the exact roosting site chosen can shift from one week to the next, depending on food, weather, and safety alike. Somewhere above a darkening field, one last ragged edge of the flock is still pouring down into the trees. Beneath the surface of rivers, lakes, and shallow coastal waters, many fish quietly ease into a state that looks remarkably like sleep once the light begins to fade, growing still, sinking lower in the water column, and becoming noticeably harder to startle than during the brighter, busier hours of daytime. Because fish lack eyelids, this resting state can be easy to miss entirely, and for a long time scientists debated whether it truly counted as sleep at all. But careful studies measuring activity, responsiveness, and recovery after disturbance have shown many species do experience a genuine, restorative form of rest. Some reef fish tuck themselves into crevices in the coral for the night, wedging their bodies into narrow gaps where predators cannot easily follow, while others simply hover motionless in open water, fins barely moving. Tonight in Reef After Quiet Reef, this same still, watchful pause is spreading gradually westward with the retreating sun. Researchers monitoring reef habitats through the night have found this settling pattern repeats with remarkable consistency, fish after fish easing into stillness as the light continues to fade. That quiet underwater stillness can rest here a moment while we follow the fading light a little further. Even honeybees, whose lives seem built entirely around ceaseless, purposeful motion, take genuine rest each night, settling within the hive and growing noticeably still, their antennae drooping slightly and their bodies becoming far less responsive to gentle disturbance than during their busy daylight foraging hours. Researchers who have studied sleeping bees closely have found that those deprived of adequate rest the night before perform noticeably worse the following day at communicating the location of food to their hive mates through their famous waggle dance, suggesting that sleep genuinely supports memory and communication, even in an insect with a brain smaller than a grain of rice. Younger worker bees, whose duties keep them inside the hive, tend to sleep more and in shorter, more frequent bursts, while older foragers venturing outside settle into longer, more consolidated rest once evening arrives. Tonight, deep within countless hives scattered across the darkening land, thousands of small bodies are already growing quietly still. This same nightly stillness recurs with quiet, dependable consistency across hive after hive, regardless of how frantic and purposeful the same colony's daytime activity might have looked only hours earlier. Inside comb after comb, a single drooping antenna is the only visible sign that anything has changed at all. Reptiles, being unable to generate their own body heat the way mammals and birds do, experience the arrival of evening rather differently, growing sluggish and cool as the surrounding air loses its daytime warmth, their whole metabolism slowing gradually in step with the falling temperature around them. This dependence on outside warmth means a resting reptile is, in a very real sense, more vulnerable during cool overnight hours than a warm-blooded animal would be, unable to muster a sudden burst of speed until the sun returns and its body temperature climbs back up again. Many lizards seek out sheltered crevices or burrows before nightfall for exactly this reason, tucking themselves away where cooler air and hidden movement will not put them at unnecessary risk. Snakes often do something similar, coiling into rocky gaps or beneath fallen logs as the light fades, remaining still through the cooling hours until morning warmth stirs them again. This same vulnerability is part of why so many reptiles favor secluded, well-insulated resting spots, places where the surrounding rock or soil can hold onto a little residual daytime warmth. Somewhere beneath a fallen log, a snake's body is already cooling toward the same temperature as the stone around it. Not every creature drifting toward stillness tonight is settling in for a long rest, since a great many species are what biologists call crepuscular, meaning their busiest hours fall specifically at dawn and dusk rather than through the deep of night or the brightest part of the day. Deer, rabbits, and a good many moths are among the most familiar examples, timing their most active foraging and movement to these two dim, transitional windows when temperatures are gentler and certain predators are less active than at full darkness or full daylight. As one wave of daytime animals eases into sleep this evening, this separate crepuscular wave is only just reaching its own busiest stretch, briefly sharing the darkening landscape with the true night dwellers before settling down themselves a little later. This overlapping handoff, one rhythm easing into another without any hard, sudden boundary between them, plays out quietly across nearly every landscape on Earth each single evening. Researchers studying these patterns note that the precise timing of dawn and dusk activity can shift somewhat with the seasons, tracking the changing length of daylight across the year. We can leave that quiet overlap exactly where it lies and turn now toward whatever comes after dark. As true darkness finally settles in across one region after another, the whole balance of activity on Earth tips, gradually and predictably, from the daytime creatures who have ruled the last many hours toward the nocturnal ones who have been waiting, patiently resting, for exactly this moment to begin their own working day. It is a genuinely vast changeover, repeated without fail every single evening across every inhabited landscape on the planet, involving countless separate species, each keeping to a schedule shaped over millions of years of gradual evolutionary adjustment. Tonight we will follow this changeover slowly and gently, moving from the birds still aloft in the darkening sky, through the hunters just beginning to stir, down into rivers and oceans, into nests built fresh each evening, into the long deep sleep of hibernation, and finally back around toward the first pale light of morning. There is nowhere in particular we need to arrive, only this long, unhurried circuit of the sleeping world to travel together. From here, we simply follow that changeover, one small corner of the world at a time, into everything the dark still holds. Perhaps no discovery about animal sleep in recent years has proven quite as startling as the finding, published by researcher Niels Rattenborg and colleagues in 2016, that great frigate birds can genuinely sleep while airborne, soaring for days at a stretch over open ocean, without ever once landing on water or solid ground. Using small devices attached to the birds that recorded brain activity during real flights, the research team found the birds experienced short bursts of slow-wave sleep while gliding on rising air currents, sometimes with only one half of the brain resting at a time and sometimes, more surprisingly still, with both halves resting briefly together. These airborne naps typically lasted just seconds at a stretch, adding up to only a small fraction of the sleep the same birds enjoyed once back on solid land, suggesting flight sleep works more as a stopgap measure than a true substitute for proper rest. Tonight, somewhere over a dark and endless stretch of ocean, a frigate bird very likely rides a warm-up draft in exactly this manner. Its wings barely move at all, the whole enormous body held aloft by nothing more than warm, rising air. Alpine swifts push this same idea of sleeping on the wing to an even more extreme conclusion, with researchers tracking individual birds that remained continuously airborne for more than 6 months at a stretch, never once touching down between leaving their breeding grounds in Europe and returning the following spring. Tiny data loggers attached to these small, fast-flying birds recorded almost no interruption in flight across this entire extraordinary stretch, meaning the birds were feeding, resting, and very likely sleeping to some degree, all while remaining aloft over Africa and the wide waters below. Scientists still do not fully understand exactly how much true sleep these birds manage during such flights, since the loggers used could track altitude and movement but not brain activity directly, leaving the precise mechanism something of an open and genuinely fascinating question. What is clear is that a bird weighing scarcely more than a large chicken egg can remain airborne, essentially living out an enormous portion of its life without ever landing at all. Let that small, tireless traveler drift on ahead of us for now, while we follow its story a little further. Common swifts, close relatives of the more extreme alpine swifts, follow a broadly similar pattern of their own, spending the vast majority of their lives on the wing and coming down to solid perches only when nesting, a behavior confirmed through careful tracking studies of birds fitted with small lightweight sensors. These birds feed entirely on flying insects snatched directly from the air, drink by skimming low over open water, and even mate briefly while airborne, so it should perhaps come as little surprise that they have also found some way to manage rest without ever needing solid ground beneath their feet. Researchers studying their flight patterns at dusk have noted swifts climbing to considerable altitude as evening falls, circling gently in what appears to be a settled, low-energy holding pattern that likely corresponds to at least some portion of restful sleep. Tonight, high above cities and open countryside alike, Dark specks too distant to properly see are very likely doing exactly this right now. Researchers following tagged birds across successive nights have found this pattern repeats reliably, evening after evening. Somewhere high above a darkened city, one small silhouette is still circling, invisible now against the last of the light. One of the quieter advantages that soaring birds like frigate birds and albatrosses enjoy while resting on the wing comes from their skillful use of rising air currents, updrafts, and thermals that let a bird's body glide forward and upward with barely any active flapping required at all, conserving enormous amounts of energy in the process. By riding these currents patiently rather than fighting against them, a soaring bird can cover extraordinary distances while burning remarkably little fuel, leaving just enough spare capacity in the brain and body for the brief, partial rest that airborne sleep provides. This same reliance on rising air also explains why so many long-distance gliding birds are found over oceans and coastlines, where warm air rising off the water and predictable wind patterns provide exactly the kind of steady lift needed to stay aloft for days without effort. Tonight, wherever warm air rises steadily off a dark and quiet sea, some soaring bird is very likely making patient, unhurried use of it. Skilled use of these rising currents can carry a soaring bird forward for hours, while its muscles do remarkably little work. Beneath it, cooling farmland and open water alike still hold whatever warm air first lifted that same tired traveler skyward. The particular trick that makes any of this possible at all is something scientists call unihemispheric slow-wave sleep, a genuinely remarkable arrangement in which one half of the brain slips into deep, restorative sleep while the other half remains fully alert, keeping watch and, crucially, keeping the animal safely oriented in space. In birds using this ability, the eye connected to the resting hemisphere typically closes, while the eye connected to the still awake hemisphere often remains open, angled forward or toward whatever direction most needs watching at that particular moment. This same remarkable trick, first studied carefully in dolphins and other marine mammals, turns out to serve flying birds just as well, letting a soaring frigate bird or swift rest one side of its brain at a time while the other continues managing flight, keeps the wings level, and so far as researchers can tell, avoids obvious hazards along its path. Tonight, high above the dark ocean, some bird's brain is very likely doing precisely this, half resting, half quietly watching. Researchers studying this pattern have found the two hemispheres do not always share the workload evenly. Half a brain sleeps, half stays lit and watchful, and from below nothing at all looks even slightly unusual. Albatrosses, those famously enormous ocean wanderers capable of circling entire hemispheres on wings that barely need to flap, are strongly suspected by researchers to make use of very similar sleep strategies while gliding for days at a time over the open Southern Ocean, though the extreme remoteness of their flights has made confirming this with the same detailed brain recordings used on frigate birds considerably more difficult so far. What scientists do know from tracking devices is that albatrosses can remain airborne, effortlessly riding wind off the wave tops in a technique called dynamic soaring, for periods stretching many days without ever touching down on water or land. Older studies of albatrosses resting on the ocean's surface itself found the birds do sleep there too, floating quietly with head tucked, but the truly long non-stop flights recorded by modern tracking clearly require some further capacity for rest while still aloft. Tonight, somewhere over vast, dark, and largely empty southern waters, a great white wandering bird glides onward, resting by degrees as it goes. Let that great slow glide carry on unwatched for now, while we turn our attention towards smaller wings. Migration season brings this same challenge of resting, while moving to an enormous number of ordinary songbirds as well, small creatures that may cover hundreds of miles in a single overnight flight, powered by little more than stored fat reserves and an internal drive that scientists still find only partly explainable. Some research on captive birds during migratory periods has found that individuals reduce their overall need for sleep quite substantially during these weeks, apparently trading some ordinary rest for extra flight time without any obvious cost to daytime alertness, a phenomenon researchers sometimes describe informally as a kind of adaptive sleeplessness. Exactly how songbirds manage brief, safe microsleeps mid-flight, if indeed they do so at all in the way soaring seabirds have been shown to, remains one of the more open and actively studied questions in the whole field, since tracking brain activity on a bird this small during real overnight flight is technically extremely difficult. Tonight, across dark skies over entire continents, countless small travelers are making exactly this same demanding overnight journey. Beneath a moon those small travelers rarely pause to notice, wingbeat follows wingbeat, hour after uncounted hour. For birds that do manage some form of rest while flying, avoiding collisions and staying properly oriented, while half asleep depends heavily on that open, watchful eye connected to the still awake half of the brain, which researchers have found tends to face specifically toward the direction of travel or toward any nearby flock mates, rather than simply pointing at random. This directional watchfulness lets a partially resting bird continue tracking its heading, sense changes in wind or altitude, and presumably notice any sudden obstacle or approaching danger, all without needing the entire brain fully awake and engaged at once. Some researchers studying frigate birds noted that birds seem to favor airborne sleep specifically while circling gently within a thermal, a relatively low-risk maneuver compared to sustained, powered, straight-line flight, suggesting the birds themselves may choose safer moments for their brief rests. Tonight, high above dark water, a resting bird's single open eye is very likely doing exactly this quiet, careful work. Researchers reviewing recorded flight paths have found remarkably few genuine mid-air collisions among birds thought to be resting this way, a small but telling clue that the system works. We can trust that single steady eye to its work for now and turn quietly toward morning's other travelers. For all these remarkable exceptions, it remains true that the overwhelming majority of the world's roughly 10,000 bird species do their real, restorative sleeping the ordinary way, perched quietly on a branch, tucked into a nest cavity, or gathered together on the ground, once evening settles in and flight is no longer required at all. Airborne sleep, however extraordinary, still appears to function mainly as a partial, stopgap measure for birds facing unusually long non-stop journeys over open ocean, rather than as any kind of preferred or complete replacement for a proper night's rest on solid ground. Once frigate birds do finally return to land after their long ocean voyages, researchers have observed them sleeping considerably more than usual for a time afterward, apparently making up at least some portion of the rest their airborne dozing could not fully provide. Tonight, while a handful of remarkable species doze along on distant winds, the vast, quiet majority of the bird world is already settling onto branch after branch below. Branch by branch, the ordinary, quieter majority of the bird world has already gone still for the night. For those ordinary perching birds, a small but genuinely clever piece of anatomy makes a full night of sleep on a narrow branch far safer than it might otherwise sound, a system of tendons running down the back of each leg that automatically tighten and lock the toes around a perch whenever the leg bends under the bird's own weight. This means a sleeping bird does not need to spend any conscious muscular effort at all gripping its branch through the night, since simple gravity and the settling weight of its own relaxed body keep those tendons pulled taut and the toes securely curled the whole time it rests. Only when the bird straightens its leg again, usually upon waking and preparing to fly, does that same tendon mechanism release its grip, allowing the foot to open freely once more. Tonight, in tree after darkened tree, countless small bodies are settling onto branches this same way, secured not by effort but by their own restful weight. This same mechanical trick appears across countless unrelated perching bird species, a solution evolution seems to have found again and again. That small mechanical certainty can rest now, holding branch after branch steady through the whole dark night. As true darkness deepens now over forest and field alike, owls begin stirring from the daytime roosts where they have spent the brighter hours dozing quietly, their remarkable senses gradually sharpening for a night of careful, near silent hunting across the darkened landscape below. An owl's face carries a shallow, dish-shaped arrangement of stiff feathers called a facial disc, which functions rather like a satellite dish, gathering faint sounds and funneling them toward the ears with striking efficiency. In several owl species, including the familiar barn owl, the two ear openings themselves sit at slightly different heights on the skull, a subtle asymmetry that lets the bird pinpoint the exact source of a sound in 3 dimensions with astonishing precision, sometimes well enough to strike accurately at prey hidden entirely beneath snow or dense grass. Tonight, this same finely tuned listening apparatus is beginning its quiet nightly work across countless dark fields at once. Researchers studying this arrangement have found the precise shape of an owl's facial disc can even be adjusted slightly by the bird itself, subtly sharpening its hearing on demand. Somewhere below, a mouse's smallest footstep in dry grass is already arriving at 2 waiting, asymmetrical ears. Barn owls in particular have become something of a favorite subject for researchers studying nocturnal hunting, since their soft, fringed wing feathers break up the turbulent air that would ordinarily create a telltale rushing sound, allowing the bird to glide toward unsuspecting prey in near total silence. This same owl typically spends its daylight hours tucked into a barn rafter, a hollow tree, or some other sheltered, shadowy roost, entering a fairly deep and settled rest that can be disturbed surprisingly easily compared to how alert and capable the same bird becomes once night falls. Studies measuring barn owl activity have found their daytime rest is not always one single unbroken stretch, but often broken into several distinct bouts, interspersed with brief periods of quiet alertness, particularly if the roost itself does not feel entirely secure. Tonight, as the light finally fades enough, barn owls across an enormous range of habitats are lifting from exactly this kind of daytime shelter to begin their hunting. Researchers have found even fairly loud daytime disturbances near a roost sometimes fail to fully rouse a resting owl. Behind one more quiet barn door, a pale shape is folded into shadow, waiting patiently through the daylight hours. It might seem, given how effectively owls hunt after dark, that they simply do not sleep at night at all, but careful observation shows the truth is somewhat more nuanced, since most owls actually rest in a polyphasic pattern, meaning they take multiple shorter bouts of sleep spread across both day and night rather than one single long uninterrupted stretch. Between bursts of active hunting through the darkest hours, An owl will often perch quietly for some minutes at a time, eyes closing briefly, before rousing itself again to continue its patrol of the surrounding territory. This flexible, broken-up pattern of rest likely helps owls stay alert enough to react instantly to a rustle of movement below, since a single long, unbroken sleep, however restful, would leave far too large a gap in their nightly vigilance. Tonight, between silent passes over open fields, more than one owl is very likely settling briefly onto a familiar branch for exactly this kind of short, watchful pause. Researchers describe this as an efficient compromise, trading one long, vulnerable stretch of sleep for many shorter, easily interrupted ones. We can leave the owl to its short, watchful pauses now and turn our attention toward the ground below. Nightjars, close relatives of the more familiar whippoor, will heard calling across summer evenings in parts of North America, take an altogether different and remarkably understated approach to nighttime rest, relying almost entirely on camouflage rather than height or hidden shelter to keep themselves safe while they doze during daylight hours. These birds settle directly onto the ground, or sometimes along a horizontal tree branch, their intricately modeled brown and gray plumage blending so completely with dead leaves, bark, and shadow that a person can walk within a few feet of a resting nightjar without ever noticing it at all. Because they hunt flying insects on the wing after dark, much like swifts, nightjars are most active precisely when nightjars are least easy to see, and their daytime stillness is so complete that they will often remain motionless even when a potential threat passes remarkably close by. Tonight, once their long hunting hours finally end, this same extraordinary stillness will settle back over them again by morning. Researchers studying nightjar camouflage have found the birds will sometimes shift their exact resting posture through the day, subtly adjusting to match shifting patterns of sunlight and shadow around them. A few feet away, dead leaves and feathers have become almost impossible to tell apart in the dark. Domestic cats, descended from a solitary desert-dwelling wildcat ancestor that hunted mainly at dawn and dusk, still carry that same crepuscular inheritance today, which is why a house cat so often seems most energetic right around sunset and again in the earliest hours before sunrise, even in a home that offers no particular reason to keep such a schedule. Across a full day, an adult cat typically sleeps somewhere between 12 and 16 hours in total, broken into numerous short naps rather than one long continuous stretch, a polyphasic pattern that likely echoes the hunting rhythms of its wild ancestors far more closely than it echoes our own single nightly block of sleep. Only a modest portion of a cat's daily sleep tends to be the deeper, more restorative kind, with the remainder made up of lighter dozing from which the animal can rouse itself again almost instantly if something interesting happens nearby. Tonight, in countless quiet homes, a cat is very likely dozing lightly on a windowsill, one ear angled faintly toward the dark outside. One ear stays angled toward the window, even as the rest of that small body sinks fully into sleep. Bats, the only mammals capable of true, sustained flight, spend their daylight hours hanging quietly in caves, hollow trees, or the eaves of old buildings, gathered often in tightly packed clusters that help conserve warmth before the whole colony stirs together as evening approaches and true darkness finally settles in. Once airborne, many bat species navigate almost entirely by echolocation, producing rapid streams of high-pitched calls, generally far above the range of ordinary human hearing, and then listening closely to the returning echoes to build a remarkably detailed picture of open space, obstacles, and prey in complete darkness. A bat may sleep for well over half of each 24-hour day when resting periods are added together, among the longest totals recorded for any mammal, likely reflecting both the enormous energy cost of powered flight and the relatively limited hours each night when flying insects are reliably plentiful enough to hunt. Tonight, as the last daylight fades from cave mouths and hollow trees alike, entire colonies are beginning to stir and lift into the darkening air together. We can let that whole dark, rising cloud of wings move on ahead of us into the night. As owls and bats take up their nighttime hunting, an enormous and largely unseen world of nocturnal insects is stirring alongside them, moths chief among them, drawn out from daytime hiding places in bark crevices and beneath leaves to begin their own nightly search for food and mates under cover of darkness. Many moth species rely on scent far more than sight to find each other in the dark, releasing faint chemical signals called pheromones that a potential mate can detect from a genuinely remarkable distance using sensitive, feathery antennae built specifically for this purpose. Daytime butterflies, close relatives of these same moths, follow the opposite schedule entirely, resting quietly with wings folded once the light fades, their eyes and behavior simply not built for operating in true darkness the way a moth's are. Tonight, as one group of six-legged travelers settles into stillness, another entirely different group is only just beginning its own quiet, purposeful work under the same darkening sky. Researchers studying this handoff have found little direct competition between the two groups, each suited to its own half of the day. One set of wings folds shut for the night, while another only now begins to test the darkening air. Red foxes, adaptable hunters found across a huge range of habitats from remote countryside to the quiet edges of cities, typically rest through the brightest hours of daylight in a den, a hollow beneath tree roots, or simply a sheltered, well-hidden patch of undergrowth, before rousing themselves as evening approaches to begin an active, wide-ranging night of foraging. Their diet is notably flexible, including small rodents, birds, insects, fruit, and particularly near human settlements, whatever edible scraps a fox happens to come across during its wandering nighttime rounds. Because foxes rely heavily on excellent hearing to locate small prey moving beneath grass, leaf litter, or even snow, a young fox spends considerable time through its early months practicing exactly this kind of careful, patient listening, before it becomes a genuinely proficient nighttime hunter in its own right. Tonight, along quiet hedgerows and darkened suburban gardens alike, a fox is very likely already moving carefully through territory it knows intimately well. Researchers tracking urban foxes in particular have found their nightly routes can grow surprisingly consistent over time. The same familiar paths walked quietly, night after night, across a well-known territory. Somewhere along a familiar hedgerow, a fox is retracing, paw by paw, a path it already knows by heart. Tarsiers, small primates found only on a handful of Southeast Asian islands, carry perhaps the largest eyes relative to body size of any mammal alive today, each single eye roughly matching the size of the animal's entire brain, an adaptation that lets remarkably little available moonlight or starlight go to waste while hunting insects through the forest canopy after dark. Because those enormous eyes are fixed rigidly in their sockets and cannot rotate the way human eyes do, a tarsier compensates with an extraordinarily flexible neck capable of swiveling its head through a very wide range of motion, letting it scan its surroundings thoroughly without ever needing to move its eyes at all. During daylight hours, tarsiers retreat to dense vegetation or hollow spaces within trees, curling into a tight, well-hidden ball to rest until the cover of evening returns once more. Tonight, deep within humid island forests, more than one pair of impossibly large eyes is already beginning to open in the gathering dark. Researchers studying tarsier vision have found their eyes so specialized for dim light that daylight itself can prove genuinely uncomfortable. We can leave those enormous, patient eyes to their work now and drift our attention toward the forest floor. Skunks, familiar across much of North America for their distinctive black and white markings and their justly famous defensive spray, follow a broadly nocturnal schedule of their own, spending daylight hours resting in a den. Sometimes one dug themselves and sometimes simply borrowed from another animal, before emerging as evening arrives to forage across open fields, woodland edges, and quiet suburban yards alike. Their diet is genuinely varied, including insects, small rodents, eggs, and various plant matter, gathered through slow, deliberate nighttime foraging aided by a strong sense of smell that more than compensates for fairly modest eyesight. A skunk's famous spray, produced by specialized glands near the base of the tail, functions specifically as a last resort defense, and the animal typically gives ample warning first, stamping its front feet and raising its tail before ever actually releasing it. Tonight, along the shadowed edges of fields and gardens, a skunk is very likely already moving through its own slow, careful nighttime routine. Researchers studying skunk foraging have found their slow, methodical pace lets them thoroughly investigate a comparatively small patch of ground each night, rather than covering long distances quickly. Somewhere along a fence line, a small striped shape works slowly through the grass, unhurried and thorough. Dolphins face a genuinely unusual challenge that land-dwelling mammals never have to solve, needing to keep breathing consciously at the surface even while resting, since unlike us, they cannot simply breathe on autopilot while fully unconscious without risking drowning. Their solution is that same remarkable unihemispheric slow wave sleep encountered earlier with soaring seabirds, in which one half of the dolphin's brain rests deeply, while the other half stays sufficiently alert to manage surfacing for air and basic muscular control. During this resting state, a dolphin typically swims slowly in a wide, gentle circle, or sometimes simply hangs nearly motionless just beneath the surface, with the eye on the side opposite the resting hemisphere often closing while the other remains open and watchful. Researchers have found dolphins can maintain this half-asleep pattern for hours at a stretch, alternating gradually which side of the brain rests, so that over a full day both hemispheres eventually receive their fair share of genuine rest. Tonight, somewhere in dark, quiet water, a dolphin drifts in exactly this slow, watchful circle. One eye stays open the whole time, tracking the dark water while the other rests completely. Sperm whales, among the largest predators on Earth and famous for diving to extraordinary depths in search of squid, were long assumed to rest much the way dolphins do, but a widely noted 2008 study using tagged whales off several coastlines found something rather different. Groups of whales floating together nearly vertically, heads near the surface, drifting almost entirely motionless for stretches of roughly 10 to 15 minutes at a time. Unlike dolphins, these whales showed very little of the slow, circling swimming pattern typically associated with active unihemispheric rest, suggesting sperm whales may experience something closer to brief, genuinely deep, bihemispheric sleep during these vertical drifting bouts, even though this still leaves them briefly vulnerable and unresponsive near the surface. Researchers estimate whales observed this way spent only a modest fraction of each day resting in this particular manner, hinting that sperm whales, much like several other large marine mammals studied so far, may simply require considerably less total sleep than their enormous size might otherwise suggest. Tonight, somewhere in deep, dark ocean water, a small cluster of whales may be hanging in exactly this quiet, upright drift. We can leave that strange, upright silence of the deep ocean behind for now and rise back toward the coast. Sea otters, spending nearly their entire lives in cold coastal waters along the Pacific Rim, have developed one particularly charming solution to the basic problem of drifting safely out to sea while resting, wrapping themselves in strands of kelp, the long ribbon-like seaweed that grows anchored to the rocky seafloor below, so that the current cannot carry a sleeping otter far from where it started. Mothers with pups are especially careful about this anchoring behavior, sometimes wrapping both themselves and their young pup together in the same patch of kelp to keep the pair safely together while resting on the water's surface. Otters resting in groups, known fittingly as rafts, will often hold paws with one another while floating, a behavior researchers believe likely helps keep the group together and may offer some small additional comfort or warmth during rest. Tonight, along quiet, kelp-lined stretches of coastline, small clusters of otters are very likely floating together in exactly this gentle, anchored fashion. Researchers have found pups briefly separated from their kelp-anchored mother call out persistently until safely reunited. A pair of small paws stays linked the whole time, drifting gently with the tide and going nowhere at all. Ducks resting together on open water, a scene familiar on almost any pond or lake, quietly demonstrate one of the clearest examples of unihemispheric sleep, protecting an entire group at once. First documented carefully by researcher Niels Rattenborg and colleagues in a widely cited 1999 study of mallard ducks resting in a row. Birds positioned at either end of the resting line were found to keep one eye open considerably more often than birds settled safely in the middle of the group, and that open eye consistently faced outward, away from the group, toward whatever direction seemed most likely to hold approaching danger. Ducks in the middle, by contrast, enjoyed the relative safety of neighbors on every side and could afford to close both eyes and rest more fully, more of the time, without that same need for outward vigilance. Tonight, on countless still ponds, a similar quiet arrangement of open and closed eyes is very likely settling into place along the water's edge. Researchers repeating this study with other resting waterfowl species since have found broadly similar patterns, suggesting this same protective arrangement is likely far more widespread than mallards alone. That quiet arrangement of open and closed eyes settles now, unhurried, along the water's edge. Fur seals offer researchers a particularly useful natural comparison for studying how sleep changes between water and land, since these animals rest quite differently depending on where they happen to be, using unihemispheric slow-wave sleep while floating in open water, much like dolphins, but switching over to fuller, more conventional bihemispheric sleep once hauled out safely onto rocks or a beach. This flexible switching suggests the specific demands of resting safely in open water, staying oriented, breathing, and watching for predators, are what push these seals toward the more complex, one-sided form of sleep, while solid, relatively predator-free ground allows for deeper, more complete rest instead. Researchers studying fur seals in laboratory tanks were able to observe this shift directly, watching the same individual animals move between resting styles, depending simply on whether they were given water or a dry platform to rest upon. Tonight, along rocky coastlines and out in open swells alike, fur seals are very likely demonstrating both of these resting styles at once, depending entirely on where each individual happens to be floating or lying. One and the same animal sleeps two different ways tonight, depending only on whether the ground beneath it is solid. Manatees, the gentle, slow-moving aquatic mammals found in warm coastal waters and rivers across parts of the Americas and West Africa, rest by settling quietly near the bottom of shallow water or floating just beneath the surface, rising every few minutes to breathe before sinking back down again into stillness. Because manatees, much like dolphins, must remain conscious enough to manage this regular breathing, researchers generally consider their resting periods to involve some form of the same unihemispheric arrangement seen in other marine mammals, though manatees have proven somewhat more difficult to study in this particular respect than more frequently researched dolphins. A resting manatee can remain submerged for a notably long stretch between breaths compared to when it is actively swimming and feeding, sometimes staying below the surface for several minutes at a stretch during its quieter periods. Tonight, in warm, shallow coastal waters, a manatee is very likely drifting gently near the riverbed, rising occasionally and unhurriedly toward the surface for air. Researchers studying manatees have found individuals often return to the same favored resting spots, apparently valuing a proven, comfortable location. We can leave that slow, rising breath to its own rhythm now and drift our attention toward the reef. Many reef fish solve the basic challenge of resting safely in open water by finding physical shelter rather than relying purely on reduced alertness, tucking themselves into crevices in the coral, beneath overhanging rock ledges, or into the sandy seafloor itself once activity slows for the night. Parrotfish take this sheltering behavior a notable step further, with certain species secreting a thin, transparent mucus cocoon around their entire body each evening, a kind of sleeping bag made from their own bodily secretions that researchers believe may help mask the fishes sent from nocturnal predators such as moray eels hunting by smell in the darkness. Producing this cocoon takes real physiological effort and appears to represent a genuine, costly investment in nighttime safety, one the fish must remake fresh again each and every evening before settling down properly to rest. Tonight, within coral formations across warm tropical seas, countless small, sheltered fish are already tucked into crevices, some of them, quite literally, wrapped inside sleeping bags built entirely from their own bodies. Researchers have found the cocoon takes roughly half an hour to fully secrete each evening, a substantial nightly investment. Wrapped inside its own thin, transparent shell, one small fish has made itself, for tonight, almost impossible to smell. Sharks present a genuinely varied picture when it comes to rest, since some species, including several requiring constant forward motion, to keep oxygen-rich water flowing steadily across their gills, a process called obligate ram ventilation, cannot simply stop swimming the way many other fish comfortably can, and instead appear to rest through periods of markedly reduced activity while still moving slowly and steadily forward. Other sharks, nurse sharks among the best studied examples, possess the ability to actively pump water across their gills using specialized muscles, freeing them to stop swimming entirely and rest motionless on the sea floor, often gathered together in loose groups inside caves or beneath rocky ledges during daylight hours. Researchers studying resting sharks have found clear evidence of reduced activity and lowered responsiveness consistent with genuine sleep in several species, even though sharks lack eyelids and, much like many bony fish, show no obvious visible sign of having actually dozed off. Tonight, in warm coastal waters, some sharks continue their slow, unbroken forward glide, while others rest, fully still, tucked beneath a familiar rocky ledge. We can leave both kinds of shark to their own separate rhythms now and turn toward the quiet riverbank. Crocodiles and alligators, ancient reptilian predators that have changed remarkably little in outward form across tens of millions of years, have also been shown by researchers to make use of unihemispheric sleep under certain conditions, keeping one eye open and the corresponding half of the brain more alert, particularly when another individual or a potential threat happens to be nearby. A study of Nile crocodiles and American alligators found this open-eyed, half-alert style of resting became noticeably more common specifically when an unfamiliar person or animal was present nearby, suggesting the behavior functions as a flexible, situational form of vigilance rather than a fixed nightly routine. When resting alone in a familiar, secure spot, these same reptiles were far more likely to close both eyes and settle into a fuller, more conventional style of rest, conserving the enormous energetic cost of staying half alert for situations that genuinely seem to call for it. Tonight, along quiet riverbanks in warmer parts of the world, some crocodiles rest with both eyes closed, while others keep a single watchful eye trained on the darkness nearby. One pale eye stays open just enough to catch the faintest ripple crossing the dark water nearby. The platypus, that famously improbable Australian mammal combining a duck-like bill, webbed feet, and the unusual habit of laying eggs despite nursing its young on milk, turns out to hold a rather surprising record among all animals studied so far, spending an extraordinarily large proportion of its sleep in a state resembling REM sleep, the phase most closely associated with vivid dreaming in humans. Laboratory studies measuring brain activity in platypuses found REM-like patterns occupying a genuinely striking share of their total sleep time, considerably more than almost any other mammal studied to date, a finding that has puzzled researchers trying to piece together how and when REM sleep first evolved among early mammal ancestors. Platypuses generally rest curled inside burrows dug into riverbanks, emerging mainly at dusk and through the night to hunt small aquatic creatures using electroreceptors in that distinctive bill rather than relying on eyesight underwater. Tonight, tucked deep within a riverbank burrow somewhere in eastern Australia, a platypus is very likely deep into exactly this unusually REM-heavy rest. Curled tightly in its riverbank burrow, that strange and ancient little body is dreaming, by every measurable sign, more than almost anything else alive. Chimpanzees, among our closest living relatives, build a completely fresh sleeping nest nearly every single evening, carefully bending and weaving together branches and leafy twigs high in a tree's canopy, until they form a springy, supportive platform sturdy enough to hold the animal's full weight through an entire night's rest. This nightly construction typically takes only a matter of minutes for an experienced adult, drawing on skills that young chimpanzees begin practicing, somewhat clumsily at first, well before they are fully weaned, gradually refining their technique through repeated childhood practice under the watchful presence of their mother. Researchers studying wild chimpanzee populations have found that nest height, thickness of supporting branches, and surrounding cover all appear to matter to the animals, suggesting real, deliberate selectivity rather than simple habit alone in choosing exactly where and how to build. Tonight, somewhere across the forests of equatorial Africa, chimpanzees are settling one by one into nests built fresh only hours earlier, high above the forest floor. Researchers who have studied this nightly construction closely note that a well-built nest can hold together securely enough to support the animal safely through even fairly restless overnight movement. High overhead, one more woven platform holds its sleeping builder steady through every small shift of the night wind. Orangutans, the large, solitary, red-haired apes native to the forests of Borneo and Sumatra, build what many researchers consider the most elaborate sleeping nests of any non-human primate studied so far, weaving a sturdy main platform from thick branches before adding a genuinely impressive array of finishing touches. These finishing touches can include a softer inner layer of smaller leafy twigs functioning much like a mattress, a folded bundle of leaves used almost exactly like a pillow, and particularly during rainy weather, an additional woven roof positioned overhead to help keep off the worst of the falling rain. Young orangutans spend several years observing and gradually practicing this nest-building skill alongside their mother, before becoming fully capable of constructing a reliable, comfortable nest entirely on their own. A genuinely extended apprenticeship reflecting just how much skill the task actually requires. Tonight, high in the rainforest canopy of Borneo or Sumatra, more than one carefully finished nest, complete with its own soft pillow and sheltering roof, is holding a sleeping orangutan safely above the forest floor. We can leave that carefully finished nest to its quiet work now and climb back down toward the forest floor. Gorillas, the largest living primates, build sleeping nests of their own each night as well, though unlike the more consistently arboreal orangutan, gorillas frequently construct theirs directly on the ground, particularly the larger, heavier mountain gorilla populations found in the misty highland forests of Central Africa, whose considerable body weight makes resting safely up in a tree considerably less practical. A typical gorilla ground nest involves bending and flattening surrounding vegetation, ferns, leafy stems, and grasses, into a rough circular depression that provides some cushioning and a small measure of insulation from the cool, damp forest floor overnight. Younger, lighter gorillas within the same group will sometimes still build their nests up in the lower branches of a tree, taking advantage of their comparatively smaller size in a way the heaviest adult males simply cannot. Tonight, scattered across misty mountain forests, family groups of gorillas are settling into freshly flattened nests built only that same evening, most of them low against the cool, damp ground. Researchers studying gorilla nest sites have found troops sometimes reuse a favored area across many nights, even while building fresh nests each evening. Flattened stems and ferns, still faintly warm, mark exactly where one heavy, gentle body settled only hours ago. Bonobos, close relatives of the chimpanzee found only in dense forests south of the Congo River, build nightly sleeping nests in much the same general fashion as their better-studied cousins, weaving branches into a supportive platform high in the forest canopy before settling in for the night, often in reasonably close proximity to other members of their social group. Bonobo society tends to be somewhat more relaxed and cooperative than that of chimpanzees, and researchers studying their nesting behavior have noted that bonobos will sometimes build nests quite near one another, or occasionally share a single larger nest between two individuals, a pattern less commonly observed among chimpanzees resting for the night. Because bonobos live only within a fairly limited and increasingly threatened stretch of Central African rainforest, much of what is known about their nightly nesting habits comes from a comparatively small number of long-term field studies conducted under genuinely challenging conditions. Tonight, somewhere within that same limited stretch of dense equatorial forest, bonobos are settling into nests built close together, high above the forest floor. Two nests, woven only an arm's length apart, hold their sleepers close through the whole quiet night. Honeybees, already mentioned briefly for the way individual workers grow still and rest each night, also demonstrate a striking form of collective, shared resting behavior within the hive itself, clustering together in dense, close-packed groups along the wax comb, where thousands of individual bodies help maintain a stable, comfortable temperature for the whole colony through the cooler overnight hours. This clustering behavior becomes especially pronounced in colder weather or climates, when bees will pack even more tightly together and generate warmth collectively through small, steady muscular movements, allowing the colony as a whole to survive conditions that would quickly overwhelm any single bee resting alone. Even while clustered this closely together, individual bees still show the drooping antennae and reduced responsiveness associated with genuine rest, suggesting the collective huddle and individual sleep are not at all in conflict with one another. Tonight, inside countless wooden hives and hollow trees alike, dense clusters of resting bees are quietly maintaining their shared warmth together through the cooling night air. We can leave that whole trembling, huddled cluster to its shared warmth now and turn toward the treetops. It is worth pausing here on a detail easy to overlook, that for the great majority of wild birds, the nest itself is not actually where the adult bird sleeps most nights at all, but rather a specialized structure built and used specifically for laying eggs and raising chicks through their most vulnerable early weeks. Once breeding season passes and any chicks have fledged successfully, adult birds of most species abandon that season's nest entirely, returning instead to their more usual overnight roosting spots, a sheltered branch, a dense hedge, or a hollow in a tree, depending on the particular species and season. Only while chicks remain in the nest, generally requiring near constant warmth and protection, does at least one parent typically spend the night actually within the nest structure itself, brooding closely over the vulnerable young. Tonight, countless nests built earlier this season sit quietly empty of any sleeping adult, their work as a nursery already finished for another year. Researchers note that mistaking an empty nest for evidence an area has been vacated can badly underestimate how many birds truly live nearby. Empty now of any sleeping adult, that same nest sits quietly in the dark, its season's real work already finished. Elephants, the largest living land animals, rest in a somewhat different manner from the nest-building primates encountered so far, sleeping only a remarkably modest amount each day, often only around 2 hours according to some closely studied wild herds, a total considerably lower than researchers once assumed for such an enormous, seemingly unhurried animal. Rather than building any kind of shelter, elephants typically rest standing for shorter dozing periods and lie down fully only for their brief stretches of deeper sleep, often gathering the most vulnerable calves toward the center of the resting herd, with older, more experienced adults positioned protectively around the group's outer edge. This careful arrangement, adults forming a kind of living perimeter around resting young, likely helps guard against predators during exactly the hours when the herd is at its most physically vulnerable and least alert. Tonight, somewhere across open African or Asian grassland, a herd of elephants is very likely gathered in exactly this same protective circle, calves resting safely near the center. At the very center of that resting circle, a calf sleeps surrounded on every side by something larger and watchful. Beavers, the industrious rodents famous for damming streams and reshaping entire wetland ecosystems through sheer persistent construction, build sturdy lodges from mud, sticks, and packed vegetation, complete with a dry, elevated resting chamber positioned safely above the waterline and accessible only through underwater entrance tunnels that keep most land-based predators out entirely. Inside this dry inner chamber, an extended beaver family, generally including the breeding adult pair along with kits from more than one recent litter, rests together through the daylight hours, since beavers themselves are largely nocturnal, emerging mainly under cover of darkness to forage and continue their tireless maintenance work on dam and lodge alike. The underwater entrance design means a beaver can slip safely into open water and disappear from a would-be predator almost instantly. A considerable safety advantage built directly into the architecture of the resting chamber itself. Tonight, within lodge after carefully built lodge scattered across countless quiet waterways, beaver families are resting together in their dry, well-hidden inner chambers. Researchers studying beaver lodges have found the mud-packed outer walls insulate so well, the inner chamber stays noticeably warmer than the winter air. We can leave that whole dry, well-hidden family to its rest now and follow the water onward. Rabbits and hares, close relatives that nonetheless differ rather sharply in their resting habits, illustrate two genuinely distinct strategies for staying safe while asleep, since rabbits typically dig or occupy extensive underground burrow systems, often shared communally among an entire social group, while hares generally forego burrows altogether, resting instead in a shallow, scraped depression in open ground known as a form. A rabbit's underground burrow network offers real physical shelter from both weather and many predators, along with a network of connected tunnels and multiple exits that can provide a genuine escape route if danger does manage to find its way inside. Hares, lacking any such underground refuge, rely instead on exceptional camouflage and powerful hind legs capable of extraordinary bursts of speed, trusting stillness and a well-chosen, well-hidden form to keep them safe until movement, rather than shelter, becomes the safer option. Tonight, underground burrows hold clusters of resting rabbits, while out in open, exposed fields, individual hares rest in flattened, carefully chosen forms of their own. Underground, a whole tangle of tunnels holds its sleepers close, while out in the open one hare lies flat and still. Tree squirrels build their own distinctive form of nightly and seasonal shelter as well, a rounded structure of woven twigs and leaves known as a dray, typically wedged securely into a fork high among tree branches, and lined inside with softer material such as moss, shredded bark, or dry grass for additional warmth and comfort. A single squirrel will often maintain more than one dray within its home territory, moving between them periodically, a habit researchers believe may help reduce the buildup of parasites in any one location, while also providing a reliable backup shelter should one dray become damaged by weather or a rival animal. Some squirrels instead choose to rest inside a natural tree cavity when a suitably sized hollow happens to be available nearby, generally considered a warmer and more secure option than an exposed woven dray whenever one can be found. Tonight, high in the bare or leafy branches of countless trees, carefully woven drays are holding curled, resting squirrels safely through the cooling night air. High overhead, a small curled shape is barely visible inside its own woven bundle of twigs and moss. Black bears entering their long winter dormancy undergo a genuinely remarkable physiological shift, their heart rate slowing dramatically from a typical resting pace down to as few as 8 or so beats per minute, even as their core body temperature drops only modestly compared to the far more extreme temperature drops seen in smaller hibernating mammals. This relatively mild drop in body temperature, along with the bear's continued ability to rouse itself relatively quickly if genuinely disturbed, has led some researchers to describe bear dormancy as a distinct category somewhat different from the deeper, more extreme hibernation seen in smaller animals, even though the bear may remain in its den without eating, drinking, or eliminating waste for months at a stretch. Remarkably, female bears may even give birth and begin nursing tiny, barely developed cubs during this same extended winter dormancy, waking only partially to tend to them before settling back into deep rest. Tonight, in dens tucked beneath fallen trees or dug into hillsides across colder northern regions, bears continue this same extraordinary months-long rest. We can leave that slow, barely beating heart to its long work now and turn our attention towards smaller sleepers. Ground squirrels, in sharp contrast to the comparatively mild dormancy of bears, undergo some of the most extreme true hibernation documented in any mammal, with their core body temperature dropping to levels just barely above freezing, and their heart rate slowing to only a handful of beats per minute for days or even weeks at a stretch. Periodically throughout the winter, a hibernating ground squirrel will actually rouse itself briefly, warming its body back up over several hours at real physiological cost, before settling back down into that same deep, cold torpor once again. A costly cycle researchers still do not fully understand the precise purpose of. These periodic arousals consume a disproportionately large share of the animal's total winter energy budget, despite representing only a small fraction of the overall hibernation period, suggesting the brief return to normal warmth serves some genuinely important biological function still being actively studied. Tonight, deep within underground burrows across colder climates, ground squirrels rest at body temperatures barely above the freezing point outside. Somewhere below the frost line, a small body lies barely warmer than the frozen ground pressed all around it. Hummingbirds, tiny birds whose extraordinarily fast metabolism demands near constant feeding through the daytime hours simply to fuel their rapid wing beats and high body temperature, face a genuine survival challenge each and every night, since going without food for too many consecutive hours could otherwise threaten to exhaust their energy reserves entirely before morning arrives. Their solution is a nightly bout of torpor, a dramatic, temporary drop in metabolic rate and body temperature that can fall by well over 90% compared to the bird's normal active state, conserving energy reserves that would otherwise be rapidly burned away, simply maintaining a resting, hummingbird's usual sky-high metabolism through the night. Coming out of this torpor each morning requires the bird to warm itself back up considerably before it can fly normally again, a process that can take a noticeable stretch of time and leaves the bird briefly vulnerable during the transition. Tonight, in gardens and forests across the warmer regions hummingbirds call home, tiny bodies are settling into exactly this dramatic nightly energy-saving state. For a few hours tonight, that tiny, tireless heart has slowed almost to stillness, waiting quietly for morning warmth. Many bat species undertake a considerably longer seasonal version of this same basic torpor strategy, gathering by the thousands or even millions within caves offering suitably cool, stable temperatures, and settling into a deep winter hibernation that can last many months in regions where flying insects, their primary food source, become entirely unavailable through the colder season. During this extended hibernation, a bat's heart rate and body temperature drop dramatically, allowing it to survive for months on fat reserves built up carefully through the preceding autumn. Though bats, much like hibernating ground squirrels, do periodically rouse themselves for brief stretches throughout the winter at real energetic cost. Researchers have found that disturbing hibernating bats, even inadvertently through cave visits during winter months, can force costly, unplanned arousals that seriously threaten a colony's careful energy budget for the entire season, which is part of why many important hibernation caves are now protected from human entry during these vulnerable winter months. Tonight, in caves offering just the right cool, stable conditions, colonies of bats rest together in exactly this deep, extended winter dormancy. We can leave that whole still, hanging colony to its long winter now and turn toward warmer ground. European hedgehogs, small spine-covered mammals found across much of the continent, prepare for winter hibernation by spending the closing weeks of autumn feeding intensively. building up substantial fat reserves before finally constructing a well-insulated nest, often tucked beneath a woodpile, inside a hollow log, or within a quiet, undisturbed corner of a garden, lined thickly with leaves and other insulating material for extra warmth. Once settled into hibernation, a hedgehog's body temperature drops to nearly match the surrounding air, its heartbeat and breathing slow to a small fraction of their normal active rate, and the animal can remain in this deeply reduced state for weeks or even months, depending on how mild or harsh the particular winter happens to be. Unusually warm spells during the winter months can sometimes rouse a hedgehog prematurely, forcing it to burn through hard-won fat reserves it had carefully set aside to last the entire season, a genuine risk that has grown more common as winter weather patterns shift. Tonight, beneath wood piles and garden hedges across the continent, hedgehogs rest in exactly this deeply lowered winter state. Beneath a familiar pile of leaves, one small spined body has slowed almost to nothing until spring finally returns. The fat-tailed dwarf lemur, a small primate found only on the island of Madagascar, holds the distinction of being the only primate confirmed by researchers to undergo true, extended hibernation, retreating into tree hollows for as long as 7 months during the island's dry season, and living entirely off substantial fat reserves stored specifically within its thick, distinctively swollen tail. Unlike many hibernating mammals in colder climates, this lemur hibernates through Madagascar's comparatively warm dry season, and its body temperature during hibernation can actually fluctuate quite widely along with the ambient temperature of its tree hollow, rather than staying tightly controlled, an unusual pattern that has made it a particularly interesting subject for researchers studying hibernation more broadly across different climates. Because this lemur is a primate, reasonably closely related to humans on the broader evolutionary tree compared to ground squirrels or bats, its unusual hibernation ability has drawn real scientific interest from researchers curious what its underlying mechanisms might eventually reveal. Tonight, within tree hollows scattered across Madagascar's dry forests, these small primates continue their long seasonal rest. Inside one particular hollow tree, a swollen, fat-filled tail is quietly keeping its owner alive through the long dry season. Wood frogs found across a wide swath of northern North America take the general idea of surviving harsh winter cold to a genuinely startling extreme, allowing much of the water within their own body tissues to actually freeze solid once temperatures drop low enough, while a natural antifreeze compound concentrated within their cells prevents the ice from causing fatal damage to those same delicate cells. During this frozen state, a wood frog's heart stops beating entirely, its breathing ceases, and by most ordinary measures the animal would appear to be dead, only to thaw gradually and resume completely normal function again once warmer spring temperatures finally return. Researchers studying this remarkable freeze tolerance have found the frog's liver rapidly converts stored energy into large quantities of glucose, flooding the bloodstream and tissues with this natural antifreeze compound within a matter of hours once freezing conditions first begin. Tonight, beneath fallen leaves and shallow soil across colder northern forests, wood frogs may already be entering exactly this remarkable frozen, suspended state. We can leave that frozen, suspended little body exactly as it is for now and trust the spring to find it. Freshwater turtles in colder climates face their own considerable winter challenge, since the ponds and lakes they depend on often freeze over completely at the surface, and their solution involves settling into the mud at the bottom of the water body and entering a slowed state called brumation, the reptile equivalent of hibernation, for the entire duration of the frozen season. Because turtles cannot breathe air while submerged beneath ice, Several species have developed the remarkable ability to absorb at least some oxygen directly through specialized tissue near the tail, a process researchers sometimes describe informally, if a little indelicately, as breathing through the rear end, which supplements the very limited oxygen the animal's dramatically slowed metabolism still requires. A brumating turtle's heart rate and overall metabolic activity drop to a tiny fraction of normal, allowing it to survive for months buried in cold mud with barely any oxygen intake at all, until warmer water finally returns each spring. Tonight, beneath the frozen surface of countless northern ponds, turtles rest quietly in the mud below, patiently waiting out the winter. Somewhere beneath the ice, a turtle's whole body has slowed to something barely distinguishable from the cold mud around it. Groundhogs, familiar to many for their brief moment of folkloric fame each February, are in fact genuine, committed hibernators, retreating into deep, specially constructed burrow chambers each autumn and remaining there in a deeply lowered metabolic state for a substantial portion of the colder months. Their body temperature dropping considerably and their heart rate slowing from a typical resting rate of around 80 beats per minute down to only a handful. Like several other true hibernators already encountered tonight, groundhogs periodically rouse themselves for brief stretches throughout the winter before settling back into deep torpor once more. A costly but apparently necessary cycle that continues until warmer weather and lengthening daylight finally trigger the animal's more permanent springtime emergence. The timing of that eventual emergence depends considerably on regional climate and the particular severity of a given winter, which is part of why the actual behavior of real groundhogs varies so much more than the tidy folklore built around a single famous individual might suggest. Tonight, in burrow chambers dug well below the frost line, groundhogs across a wide swath of the continent continue their own long winter rest. Far below the frost line, one more slow heartbeat keeps its quiet count through the coldest months of the year. Stepping back across all these varied deep sleepers, the underlying purpose of torpor and hibernation alike comes down to a fairly simple and elegant piece of biological arithmetic. Since dramatically lowering body temperature and metabolic rate allows an animal to survive for extended stretches on far less stored energy than staying fully active and warm would ever require. A genuinely valuable option whenever food becomes scarce or temperatures drop low enough to threaten survival outright. Some animals, hummingbirds among them, use this strategy nightly on a small scale simply to bridge the gap until morning, while others, ground squirrels and hibernating bats prominent among them, commit to a single extended seasonal version lasting months at a stretch. And still others, wood frogs perhaps most dramatically of all, push the underlying principle to its most extreme biological limit. Whatever the particular scale involved, the core trade-off remains remarkably consistent across every one of these very different animals. Tonight, across countless burrows, tree hollows, caves, and quiet muddy pond bottoms alike, this same ancient energy-saving strategy continues its slow, patient work. We can rest with that whole idea a moment longer and let the coldest sleepers keep their own patient time. Horses possess a genuinely clever piece of anatomy known as the stay apparatus, a coordinated system of tendons and ligaments in each leg that can lock the joints securely into place with remarkably little ongoing muscular effort required, allowing a horse to doze lightly while standing upright for hours at a stretch without ever risking a fall from relaxed, sleeping muscles. This standing rest, however, only ever provides the lighter stages of sleep, and horses genuinely require some amount of time lying fully down on the ground each day to reach the deeper stages associated with REM sleep, a state in which the body's muscles relax so completely that remaining upright simply is not physically possible. A horse deprived of adequate lying down time, whether through injury, discomfort, or an unfamiliar and stressful environment, can actually begin to show real signs of sleep deprivation, since standing dozing alone cannot fully substitute for that periodic deeper rest. Tonight, in field after quiet field, horses stand together dozing lightly on locked legs, while every so often one lowers itself carefully to the ground for something deeper. One horse, legs locked and perfectly still, has barely shifted its weight in the better part of an hour. Flamingos resting on one single thin leg present one of the more instantly recognizable images in the whole animal kingdom. And researchers studying the mechanics behind this famous pose have found it actually requires strikingly little active muscular effort at all, relying instead on a passive, largely mechanical arrangement of joints and tendons that can hold the legs steadily locked in place with the bird's weight settled naturally over a stable center of gravity. Rather than serving any particularly dramatic purpose, this one-legged stance appears to function mainly as a simple, practical way of reducing heat loss, since tucking one leg up close against the warm feathered body reduces the total surface area exposed to cool water or air at any given moment. Flamingos will periodically switch which leg bears their weight, alternating the resting leg much the way a person might shift their stance while standing for a long stretch, without ever needing to fully wake or become genuinely alert to do so. Tonight, along shallow lagoons and salt flats worldwide, flamingos stand resting in exactly this quiet, familiar, one-legged pose. One thin leg tucked warm against the feathers is doing all of tonight's quiet, patient work of standing still. Bats, already encountered hanging together in colonies through their long winter hibernation, rest the same way through ordinary nights as well, hanging upside down by their feet from a cave ceiling, tree branch, or building eave. A posture made comfortable and genuinely effortless by a clever tendon arrangement in their feet, very similar in principle to the one that lets perching birds grip a branch securely without conscious effort. As a bat's body relaxes and its own weight pulls gently downward, those same tendons draw the claws automatically into a tight, secure closed grip, meaning the animal expends essentially no ongoing muscular energy at all, simply hanging there through hours of rest. This same passive grip is part of why a bat can remain safely suspended even while completely relaxed or fully asleep, since letting go would actually require deliberate muscular effort rather than happening by accident through simple relaxation. Tonight, in caves, hollow trees, and quiet building eaves worldwide, countless bats hang resting in exactly this effortless, upside-down grip. We can leave that whole effortless, upside-down colony to its rest now and turn toward taller grass. Giraffes, the tallest living land animals, get by on remarkably little sleep compared to almost any other mammal studied, with careful field observations of wild giraffes finding total daily sleep time averaging somewhere around 4.5 to 5 hours, and much of that broken into very brief episodes lasting only a few minutes each rather than one long continuous stretch. A giraffe's deepest sleep, the kind involving genuine muscular relaxation, typically happens only while the animal is kneeling down with its long neck curled back against its own body, a posture that leaves it considerably more vulnerable to predators, and is consequently held for only very short periods at a time before the giraffe rouses itself again. Much of the rest of a giraffe's limited daily sleep quota is instead taken standing upright, dozing lightly in brief bursts, a strategy that trades deeper, more restorative rest for the greater safety that staying upright and ready to flee provides on the open, predator-filled savanna. Tonight, somewhere across open grassland, a giraffe folds its long legs and curls its neck back for one of these brief, precious, deeper rests. For just a few minutes tonight, that impossibly long neck is finally, briefly, curled all the way back. Elephants, whose protective circling behavior around resting calves we already touched on, similarly combine both standing and lying rest depending on how deep a particular period of sleep needs to be, dozing lightly while standing for much of their limited daily rest, and lying fully down on their side only for the brief stretches of deeper REM sleep that standing simply cannot accommodate. Field researchers tracking wild elephants have found they may go multiple consecutive nights without lying down fully at all if conditions feel unsafe or unsettled, apparently able to tolerate a fair amount of missed deep sleep before any lying down rest becomes strictly necessary again. When an elephant does finally lie down, it typically chooses a spot that feels reasonably secure, often near other resting herd members, and remains down for what tends to be a comparatively brief period before rising again to resume its mostly standing daily rhythm. Tonight, across open grassland and forest alike, elephant herds rest mostly on their feet, with only the occasional individual actually lying fully down nearby. Most of that herd is still on its feet tonight, only one or two shapes actually lying down in the grass. Sloths, famous the world over for their extraordinarily slow, deliberate movements, spend a great deal of their life hanging from tree branches by strong, curved claws, and much of their resting time follows this same suspended posture, the animal's low muscle mass and naturally sluggish metabolism making prolonged, motionless hanging a genuinely comfortable and low-effort way to rest. Interestingly, careful field studies of wild sloths have found their actual daily sleep totals run considerably lower than earlier estimates drawn mainly from captive animals once suggested, closer to something like 10 hours rather than the 15 or more hours long assumed, a reminder that captivity itself can noticeably shift an animal's natural resting patterns. Sloths generally choose resting spots high in the forest canopy, partly concealed among leaves and moss growing on their own fur, which together with their remarkably slow movement helps them go largely unnoticed by predators scanning the canopy from below. Tonight, high in tropical forest canopies, sloths hang quietly suspended, their pace of rest every bit as unhurried as their pace of movement. We can leave that whole slow, unhurried shape hanging quietly now and drift our attention towards smaller branches. Koalas hold one of the very highest recorded sleep totals of any mammal, resting for somewhere around 18 to 20 hours out of each 24-hour day, according to most field and captive studies alike. A genuinely enormous total explained largely by their remarkably poor diet, since eucalyptus leaves, virtually the only food koalas eat, are low in usable energy and contain toxic compounds the animal's body must work hard to process safely. This combination of poor nutrition and the ongoing metabolic cost of detoxifying eucalyptus compounds leaves a koala with comparatively little spare energy for extended activity, and long stretches of rest wedged securely into a tree fork help the animal conserve what limited energy its diet actually provides. Despite spending such an overwhelming share of their lives resting, koalas are not considered true hibernators or torpor users in the way ground squirrels or hummingbirds are, since their body temperature and metabolism, while low energy overall, do not drop nearly as dramatically during ordinary daily rest. Tonight, wedged securely into eucalyptus branches across the forests of eastern Australia, koalas continue this same extraordinarily long daily rest. Wedged into a fork of eucalyptus branches, one more gray shape has barely stirred in the better part of a day. Cattle, much like horses, are capable of dozing lightly while standing upright, a useful ability for a grazing herd animal that benefits from being ready to move quickly if a predator or other disturbance suddenly appears nearby. Though cattle, again like horses, still require some amount of time lying down to reach their deeper stages of sleep. Standing rest in cattle connects closely with rumination as well, the slow, repeated process of bringing partially digested plant matter back up from an earlier stomach chamber to chew more thoroughly. A task cattle often perform while resting quietly, whether standing or lying down, and one that can occupy a genuinely substantial portion of each day. A resting, ruminating cow chewing steadily in a quiet field is, in a real sense, doing two useful things at once. Resting its body somewhat while its digestive system continues the patient, ongoing work of properly breaking down tough, fibrous grass. Tonight, across pastures and paddocks worldwide, cattle stand or lie quietly together, many of them slowly chewing as they rest. Somewhere in that quiet field, a slow, steady jaw is still working through the very last mouthful of the evening. Meerkats, small, highly social mongooses found across the arid regions of southern Africa, rest together each night deep within an extensive underground burrow system, an entire extended family group, sometimes numbering 20 or more individuals, piling closely together in a tight, huddled mass within one of the burrow's deeper chambers, sharing warmth against the surprisingly cold desert nights. This close nightly huddling appears to serve much the same thermoregulatory purpose as huddling behavior seen in several other small, socially living mammals, letting the whole group conserve considerably more body heat together than any single meerkat could manage resting alone in the same cool underground space. Individual positions within this nightly sleeping pile are not entirely random either, with researchers noting that more central positions, offering the greatest warmth and the least direct exposure to a burrow entrance, tend to be occupied somewhat differently by different members of the group depending on social standing and recent behavior. Tonight, deep within burrow systems scattered across the dry southern African landscape, meerkat families rest together in exactly this close, huddled pile. We can leave that whole close, breathing pile of small bodies to its shared warmth now and move on. Ducks and many other waterfowl frequently rest with the head turned backward and tucked snugly beneath one wing, a compact posture that helps conserve body heat by keeping the head, which loses warmth quickly, pressed close against the warmer feathered body rather than left exposed to cooler surrounding air. This same posture is often combined with the one-legged standing stance already seen in flamingos, one leg tucked up warmly against the body's feathers, while the other bears the bird's full weight, a pairing that maximizes heat conservation from two directions at once during a single resting bout. Waterfowl resting on open water rather than standing on shore will often simply float with the head tucked in this same manner instead, letting buoyancy handle support entirely while the bird's core stays comfortably warm beneath its own feathers. Tonight, along the still edges of ponds and lakes worldwide, countless birds rest in exactly this familiar, tucked, one-legged posture, heads pressed warmly beneath a wing. Researchers studying this posture across many different waterfowl species have found it appears with remarkably similar form nearly everywhere ducks, geese, and swans are found resting together. One small head pressed warm beneath a folded wing is the only part of that bird still visible at all. REM sleep, short for rapid eye movement sleep, was first carefully identified and described in humans during the early 1950s by researchers studying sleeping volunteers in a laboratory, noticing periods marked by quick, darting eye movements beneath closed lids alongside brain activity that, on recording equipment, looked surprisingly similar to full wakefulness despite the person remaining genuinely and deeply asleep throughout. In the decades since that original discovery, researchers have identified broadly similar REM-like sleep stages across an impressively wide range of other mammals, and in birds as well, suggesting this particular pattern of brain activity during sleep likely traces back a very long way through evolutionary history, rather than being some late, isolated human development. Because REM sleep in humans correlates so strongly with vivid, narrative dreaming, its discovery in so many other species has understandably fueled genuine scientific curiosity about whether animals experience something at least somewhat comparable during their own REM periods. Tonight, in sleeping bodies across an enormous range of species, this same rapid, distinctive pattern of brain activity is very likely occurring in more than one place at once. Somewhere right now, more than one closed pair of eyes is moving, quick and small, beneath its own lids. Cats and dogs resting nearby often provide some of the most immediately relatable evidence for animal dreaming that most people ever encounter directly. Twitching their paws, moving their whiskers, occasionally producing small muffled sounds, or shifting their eyes rapidly beneath closed lids during clearly identifiable REM sleep periods. Behavior that certainly looks, to any watching owner, remarkably like the physical residue of some kind of active inner experience. A well-known but ethically striking older study involving cats with a specific area of the brainstem, experimentally disabled, found the animals would, during REM sleep, actually act out complex movements, stalking, pouncing, even apparent attacking motions, behavior ordinarily suppressed by that brainstem region precisely to keep a dreaming animal's body from acting out whatever its brain happens to be doing during REM sleep. This finding strongly suggests that under normal circumstances, an animal's body is deliberately held still during REM sleep specifically to prevent it from physically acting out active, dream-like brain activity. Tonight, on countless beds and rugs, a sleeping cat or dog is very likely twitching gently through exactly this same suppressed, dream-rich stage of sleep. We can leave those twitching paws to whatever quiet business they are chasing and turn toward stranger dreamers. Birds also experience clearly identifiable REM sleep, though generally in notably shorter bursts than the longer REM periods typical of many mammals, sometimes lasting only a few seconds at a stretch, and researchers studying sleeping birds have documented small, visible head movements and occasional brief eye movements occurring during these short REM episodes that echo in miniature, some of the same physical signs seen in dreaming mammals. Because a bird's REM bouts tend to be so brief, researchers have had to develop specialized recording techniques capable of reliably capturing these fleeting episodes, work that has considerably expanded scientific understanding of just how widespread REM sleep truly is across the wider animal kingdom beyond mammals alone. Some researchers studying birds have proposed that these brief REM episodes might serve a similar underlying function to mammalian REM sleep, supporting memory processing or emotional regulation, though confirming anything resembling actual dream content in a bird remains, understandably, extremely difficult to establish with any real confidence. Tonight, in nests and roosts across the world, sleeping birds are experiencing many brief, rapid bursts of exactly this same distinctive REM activity. For just a second or two at a time, one more small head jerks faintly, then settles back into stillness. Octopuses, intelligent invertebrates entirely unrelated to vertebrate animals on the evolutionary tree, have produced some of the most visually striking evidence, yet for something resembling dream activity outside the vertebrate world, with researchers documenting sleeping octopuses cycling rapidly through dramatic changes in skin color and texture during a distinct active sleep phase, shifting through mottled patterns, sudden darkening, and even brief muscular twitching within a matter of seconds. A widely discussed 2021 study led by researcher Silvia Medeiros and colleagues, building on earlier observations, found this active sleep phase in octopuses shared several measurable characteristics with vertebrate REM sleep, despite octopuses having evolved a nervous system entirely independently from our own, raising genuinely fascinating questions about whether something resembling dreaming might have arisen more than once across very different branches of the animal kingdom. Because octopus skin color and pattern shifts often mirror how the animal signals mood, camouflage, or hunting behavior while fully awake, some researchers have speculated, cautiously and without firm proof, that a sleeping octopus's shifting colors might reflect something like a replayed memory or experience. Across its own skin, one shifting shape is cycling through colors it has no obvious reason left to hide. The platypus, already noted earlier for its unusually high proportion of REM-like sleep, presents researchers studying the deep evolutionary history of sleep with a genuinely puzzling contradiction. Since platypuses belong to the monotremes, an ancient and highly distinct branch of mammals that split off from the rest of the mammal family tree tens of millions of years before REM sleep was traditionally assumed to have first evolved. Finding such prominent REM-like activity in an animal from this particular ancient lineage has led some researchers to suggest that REM sleep, or at least some earlier ancestral version of it, may actually predate the split between monotremes and all other mammals by a considerable margin, pushing its evolutionary origins back further than scientists once assumed. Other researchers remain more cautious, noting that brain activity resembling REM sleep on recording equipment does not automatically prove the platypus experiences anything resembling actual dreaming in a subjective sense, a distinction that remains genuinely difficult to settle with certainty for any non-human animal. Tonight, this same quiet evolutionary puzzle continues resting, unresolved, alongside a great many platypuses themselves. We can leave that whole unresolved evolutionary question to rest quietly for now and turn towards smaller singers. Zebra finches, small, popular songbirds frequently studied by neuroscientists interested in how vocal learning works, have offered researchers some particularly compelling evidence connecting sleep directly to memory and skill practice. Since young finches learning their species' distinctive song show patterns of neural activity during sleep that closely echo the specific neural firing patterns recorded, while the same bird was actively singing or practicing that song while awake. This phenomenon, sometimes called neural replay, suggests the sleeping bird's brain may be quietly reinforcing or rehearsing the complex motor sequences involved in singing, effectively continuing to practice, at some level, even while fully asleep and outwardly still. Researchers have found that disrupting a young finch's sleep during this crucial song-learning period can measurably impair how well it eventually masters the fully accurate adult version of its species' song, underscoring just how functionally important this sleeping rehearsal process appears to be. Tonight, in aviaries and wild habitats where zebra finches rest, young birds may be quietly replaying, deep within a sleeping brain, the songs they are only just beginning to learn. Somewhere in a small sleeping skull, the shape of tomorrow's song is already being quietly rehearsed. Laboratory rats have provided some of the clearest and most influential experimental evidence linking sleep to memory in the entire animal kingdom, most famously through a landmark 1994 study by researchers Matthew Wilson and Bruce McNaughton, who recorded activity from neurons in a rat's hippocampus, a brain region central to spatial memory, both while the animal actively explored a maze and later while it slept. The researchers found that specific patterns of neural firing recorded while a rat ran through a particular sequence of the maze would reappear in strikingly similar order, while that same rat slept afterward, strong evidence that the sleeping brain was actively replaying, and quite possibly consolidating into longer-term memory the rat's earlier waking experience. This landmark finding helped establish hippocampal replay during sleep as a genuinely important and still actively studied mechanism underlying memory consolidation, one that subsequent research has since found evidence for across a considerably wider range of species beyond rats alone. Tonight, in sleeping rodent brains the world over, something resembling this same quiet, patient replay of the day's experience is very likely unfolding. We can leave that whole quiet, internal replay running now, unwatched, and turn our attention towards stranger minds still. Elephants, whose comparatively modest daily sleep total has already come up more than once tonight, appear to experience correspondingly limited amounts of REM sleep as well. A reasonable enough outcome given how little total sleep time they have available each day for REM to occupy in the first place. Since REM sleep in most mammals studied so far requires lying down fully in a genuinely relaxed, muscularly loose state that standing rest simply cannot provide. Researchers tracking wild elephants have found some individuals may go without any measurable REM sleep at all on a given night, particularly during stretches when the herd does not feel settled enough to risk the extended vulnerability that lying fully down for deeper sleep requires. Though elephants do not appear to suffer any obvious ill effects from these occasional REM-free nights. This pattern raises interesting broader questions for researchers about just how essential REM sleep genuinely is across different species, since an animal capable of skipping it periodically without apparent harm complicates any simple, universal story about its precise biological necessity. Some nights, that whole enormous body never once slips into REM sleep at all, and seems none the worse for it. Fish and reptiles occupy a genuinely more uncertain, actively debated position in this broader conversation about REM sleep and dreaming, since researchers have found some brain activity patterns during rest in certain reptiles, bearded dragons among the more closely studied examples, that show at least some resemblance to the alternating slow wave and REM-like cycles seen in birds and mammals, though considerably shorter and less pronounced overall. Fish sleep studies face their own particular challenges, since fish brains are organized quite differently from those of land vertebrates, making it genuinely difficult for researchers to identify clear equivalents of the specific brainwave patterns used to define REM sleep in warmer-blooded animals with more familiar brain structures. Because of these genuine difficulties, most researchers remain appropriately cautious about drawing firm conclusions regarding dreaming, or anything resembling it, in fish and most reptiles, treating this as an open and actively evolving area of ongoing scientific research rather than a settled matter either way. Tonight, this same honest scientific uncertainty rests quietly alongside the sleeping fish and reptiles it concerns. What that sleeping fish actually experiences, if anything, remains one more small, honest gap in what we know. Taken together, this whole wide-ranging body of research across birds, mammals, and even a boneless, thoroughly alien creature like the octopus points toward one broadly shared underlying idea, that whatever dreaming or dream-like brain activity actually accomplishes, memory consolidation, emotional processing, or perhaps the quiet rehearsal of important skills, appears valuable enough that evolution seems to have arrived at some version of it independently, more than once across genuinely different branches of the animal kingdom. Scientists remain understandably careful about claiming too much certainty regarding what any given animal subjectively experiences during these active sleep states, since even the most detailed brain activity recording cannot fully answer that deeper, harder question of inner experience on its own. Still, the accumulated evidence gathered across so many very different species makes it reasonable to imagine that dreaming, in some form, is a considerably more widespread feature of animal life than most people might otherwise assume. Tonight, across sleeping minds of every size and shape, something like this same quiet, restorative process is very likely unfolding somewhere, patiently, in the dark. We can rest with that whole wide, uncertain possibility a moment longer before the night carries us onward. Meerkats, already seen huddled together each night deep within their burrow system, also rely on a remarkably organized system of vigilance during their active daytime foraging, with one or more individuals taking up an elevated sentinel position, perched upright on a termite mound or similar raised vantage point, scanning the surrounding landscape carefully for approaching predators, while the rest of the group forages with its head down. A sentinel meerkat will typically hold this watchful post for a period lasting anywhere from a few minutes to perhaps half an hour before another member of the group takes over the duty, a rotation that spreads the responsibility and the associated cost of missed foraging time reasonably evenly across the wider group over the course of a day. Researchers studying meerkat sentinel behavior have found that a clear, distinctive alarm call from a sentinel spotting real danger sends the entire foraging group diving for the nearest burrow entrance within seconds. A fast, well-coordinated response built on considerable mutual trust between group members. Researchers studying this rotation have found well-fed sentinels volunteer for the watchful post more readily than hungrier group members. Atop its termite mound, one small upright shape keeps turning its head, scanning ground the others have stopped watching. Musk oxen, large, shaggy-coated mammals adapted to some of the harshest Arctic conditions on Earth, employ one of the more visually dramatic group defense strategies in the entire animal kingdom when threatened, forming a tight defensive circle with the largest, most capable adults facing outward and any calves or more vulnerable individuals sheltered safely within the protected center of the formation. While this particular formation is most closely associated with active defense against approaching wolves rather than ordinary daily rest, herds resting together through the long, dark Arctic winter nights similarly tend to stay closely clustered, gaining real safety in numbers along with valuable shared warmth against the extreme cold, even without adopting the full, tightly organized defensive circle, unless a genuine threat actually appears nearby. This same fundamental herd cohesion, staying physically close together through both rest and active defense alike, has likely helped musk oxen survive successfully across some of the coldest, most exposed landscapes any large mammal anywhere on Earth is regularly asked to endure. Tonight, across windswept Arctic tundra, musk ox herds rest close together against the cold and dark alike. We can leave that whole shaggy, close-packed herd to the cold and dark now and turn our attention south. Geese and many other social waterfowl demonstrate a broadly similar principle of shared vigilance while resting together in a group, with careful field observations finding that individual birds positioned at the outer edge of a resting flock keep their eyes open and scan the surroundings considerably more often than birds settled safely toward the group's protected center. This pattern, sometimes referred to by researchers as the many eyes effect, allows the flock as a whole to maintain reasonably continuous collective vigilance against approaching predators, even though no single individual bird needs to stay fully alert for the entire resting period, since at any given moment enough birds around the group's edges are likely to have at least one eye open. Larger resting flocks generally allow each individual bird slightly more time with both eyes fully closed compared to smaller groups, since the total pool of watchful eyes scanning the surroundings simply grows larger as more birds join the resting group together. Tonight, on open water and quiet fields alike, resting flocks of geese continue this same quietly effective, shared system of collective watchfulness. Along the flock's outer edge, one head after another keeps lifting, checking, and settling back down again. Baboons, highly social primates found across much of Africa and parts of the Arabian Peninsula, generally choose their nightly sleeping sites with real deliberate care, favoring tall trees or steep, difficult to access rocky cliff faces specifically because these locations are considerably harder for ground-based predators, leopards chief among them, to approach undetected during the vulnerable overnight hours. An entire baboon troop, which can number anywhere from a few dozen individuals to well over 100 in some populations, will often return to the very same trusted sleeping site, sometimes the exact same cliff or grove of trees, night after night for extended stretches, presumably because a proven, reliably safe location is simply too valuable to abandon without genuinely good reason. Researchers studying baboon troops have noted that competition for the safest, most sheltered positions within a chosen sleeping site can sometimes reflect a troop's broader internal social hierarchy, with more dominant individuals occasionally securing the most protected spots for themselves. Tonight, along familiar cliff faces and favored groves of trees across the African landscape, baboon troops are settling into exactly these same carefully chosen, trusted sleeping sites. High on that same familiar cliff face, a whole troop has settled again tonight, exactly where it settled the night before. Lions, among the most famously idle of Africa's large predators when it comes to daily activity, rest for a genuinely enormous portion of each day, commonly sighted at somewhere around 18 to 20 hours, when all their various dozing and sleeping bouts throughout a full day are added together. A striking total that reflects both the very high metabolic cost of actually hunting successfully and the considerable safety that comes from resting together within a cooperative pride. Because lions generally rest in these same social groups, sharing both territory and the responsibility of watching for potential threats or rival prides, individual members can afford to sleep quite deeply, and for such extended periods without leaving the group as a whole meaningfully vulnerable, since at any given moment at least some pride members are likely to be at least partially alert. This deeply social approach to extensive daily rest stands in real contrast to more solitary predators, who cannot risk nearly so much extended vulnerability alone. Tonight, across the open grasslands of Africa, prides of lions continue their characteristically long, shared periods of rest. We can leave that whole sprawled, unhurried pride to its rest now and turn our attention toward open water. Starlings gathering into the vast evening murmurations mentioned earlier eventually settle for the night into a shared communal roost, sometimes numbering many thousands of individual birds packed closely together across the branches of a single stand of trees or a dense reed bed. A nightly arrangement that offers real safety in numbers against nighttime predators in much the same fashion as many of the daytime vigilance strategies already discussed. Researchers studying these enormous communal roosts have proposed several possible additional benefits beyond simple predator safety, including valuable shared warmth on colder nights, and the intriguing possibility that birds gathered together in one place might more easily share information the following morning about especially productive feeding areas discovered the day before. Individual positions within these packed communal roosts are not entirely random, with some research suggesting that more experienced or socially dominant birds tend to favor the warmer, better protected interior positions over the more exposed spots along the roost's outer edge. Tonight, in reed beds and dense stands of trees across the countryside, enormous flocks of starlings are settling together into exactly these same crowded communal roosts. Deep inside that packed, murmuring roost, thousands of small bodies are sharing warmth none of them could manage alone. Many schooling fish similarly gain a real measure of safety through numbers while resting together at night, gathering in tighter, denser formations after dark than they typically maintain during more actively swimming daylight hours. A pattern researchers believe likely reduces each individual fish's personal odds of being the one singled out and caught should a nocturnal predator happen to approach the resting school. Unlike the more active, coordinated sentinel systems seen in meerkats or the alternating open eyes documented in resting ducks, most schooling fish do not appear to maintain any single designated watchful individual during rest, relying instead on the simple mathematical safety that comes from sheer density and numbers alone, since a predator attacking a large, tightly packed group faces real difficulty singling out and successfully catching any one particular fish. Some reef species do show modestly reduced responsiveness while resting within a school compared to resting alone, suggesting the group itself provides enough passive safety on its own. Tonight, in reef crevices and open water alike, schools of fish rest together in exactly this dense, quietly protective formation. We can leave that whole dense, protective school to drift on now and turn our attention toward open grassland. Wildebeest, the large grazing antelope famous for their immense seasonal migrations across the plains of East Africa, similarly rest together in large, closely packed herds through the night, relying heavily on the same basic safety in numbers principle already seen across so many other social grazing and herding animals encountered tonight. Individual wildebeest within a resting herd show noticeably varied levels of alertness at any given moment, with careful field observations finding that animals positioned nearer the herd's outer edges tend to lift their heads and scan the surrounding darkness considerably more often than animals resting more centrally within the tightly packed group. This same basic pattern, greater vigilance at the edges and greater relative safety, and correspondingly deeper rest toward the protected center, echoes strikingly closely the arrangement already seen in resting ducks and geese, suggesting a genuinely broad, independently evolved principle shared across an enormous range of otherwise very different social animals. Tonight, across the open plains of East Africa, wildebeest herds rest together in exactly this same familiar pattern of watchful edges and calmer centers. Along the herd's edges, heads keep lifting toward the dark, while closer to the center, nothing stirs at all. Dolphin pods resting together at night, extending the unihemispheric sleep already discussed for individual dolphins, often coordinate their resting behavior as a coherent group, swimming slowly in loose synchrony, and maintaining fairly close physical proximity to one another rather than simply drifting apart and resting entirely independently through the night. Researchers studying resting dolphin pods have observed individuals adjusting their swimming speed and direction to stay reasonably close to nearby pod members even while resting. A coordinated pattern that likely offers some of the same collective safety benefits already seen in resting fish schools, bird flocks, and grazing herds, while still allowing each individual dolphin to manage its own particular unihemispheric resting cycle. Mother and calf dolphin pairs in particular tend to rest in especially close proximity, with the calf typically positioned protectively near its mother throughout the resting period, mirroring the protective positioning already seen in resting elephant herds. Tonight, in dark coastal waters and open ocean alike, dolphin pods drift together in loose, coordinated rest, calves held close beside their mothers throughout. Close beside one slow-moving shape, a smaller one stays tucked in tight, matching every gentle turn. Elephant family groups, generally led by an experienced older matriarch, whose accumulated knowledge of the surrounding landscape and its dangers benefits the entire group considerably, rest together each night in exactly the kind of close, protective arrangement already described earlier, with vulnerable calves gathered safely toward the center of the group and larger, more capable adults positioned protectively around the outer edge. This same close family structure persists through waking hours as well, with the matriarch generally leading the group's movements and decisions based on her own long-accumulated experience, a role that becomes especially valuable during periods of genuine danger or environmental hardship when sound, well-informed group decisions matter most. Researchers studying elephant social structure have found that groups led by older, more experienced matriarchs tend to respond more effectively to genuine threats than groups led by younger matriarchs, underscoring just how much collective safety within these family groups depends on accumulated knowledge passed down through many years of shared experience. Tonight, across open grassland and forest edge alike, elephant families rest together in exactly this same careful, matriarch-led protective formation. We can leave that whole close, matriarch-led family to its rest now and turn toward the coming dawn. As the eastern sky begins its own slow, gradual transformation from deep night toward the first pale hints of coming daylight, an extraordinary wave of bird song begins rippling outward across forests, hedgerows, and city parks alike. A phenomenon so consistent and so widespread across the world that ornithologists have long given it its own specific name, the dawn chorus, marking one of the most reliably predictable daily events in the entire natural world. Researchers studying exactly why so many birds choose this particular pre-dawn window to sing so intensively have proposed several complementary explanations, including the fact that cool, still, humid early morning air tends to carry sound considerably farther and more clearly than the warmer, more turbulent air typical of full daylight hours. Male birds singing during this crucial early window are very likely working to reassert their territorial claims after the long, quiet night, and to advertise their continued fitness and availability to potential mates, all while the low light still makes active foraging considerably less productive than simply announcing their presence through song instead. Somewhere just ahead of true daylight, one clear voice has already broken the long silence of the night. Robins and thrushes are frequently among the very earliest and most reliable voices to join this pre-dawn chorus, their clear, fluting songs often beginning while the sky still holds onto a considerable amount of genuine darkness, well before most other birds have stirred meaningfully from their overnight roosts at all. Researchers studying the precise order in which different species join the dawn chorus have found this sequence is remarkably consistent from morning to morning within a given habitat, generally following predictable patterns related to a bird's eye size, its typical diet, and how much available light its particular visual system actually requires before active foraging becomes genuinely worthwhile. Birds with especially large eyes relative to their body size, robins prominently among them, can apparently make good use of even quite dim early morning light, letting them confidently begin singing and eventually foraging well before species with comparatively smaller eyes feel it worthwhile to stir from their own overnight roost. Tonight's long darkness, wherever it happens to be gradually lifting right now, is very likely already carrying the very first clear notes of exactly this same familiar, reliable morning sequence. Before almost anything else stirs, one fluting voice is already threading its way through the last of the dark. Primates waking together as a group, chimpanzee and gorilla troops alike, generally begin their own morning routine with a notably unhurried, gradual transition from restful stillness back toward full daytime activity, often including extended bouts of social grooming between individuals shortly after waking. a behavior that appears to serve both practical hygienic purposes and a genuinely important function in maintaining and reinforcing close social bonds within the group. This morning grooming period frequently continues for a considerable stretch of time before the group actually sets off to begin its day's real business of foraging for food, suggesting that easing gently and sociably back into full wakefulness carries real value of its own for these deeply social animals, rather than waking simply meaning an instant, abrupt return to full activity. Younger members of the group often participate actively in this morning grooming ritual as well, gradually learning through repeated daily practice exactly which social bonds and relationships within the wider troop matter most and deserve this kind of careful, ongoing attention. Tonight's slow transition toward morning will very likely be met before long with exactly this same gentle, unhurried, deeply social waking ritual. We can leave that whole slow, sociable morning ritual to unfold now and turn toward the hunters heading home. Nocturnal hunters whose long working night we followed earlier are, by this hour, generally winding their own activity back down again. Owls returning to their familiar, sheltered daytime roosts and bats streaming back into caves or hollow trees in the reverse of the very same evening departure already described. Their own long nights hunting drawing gradually to a close as the growing daylight makes continuing to hunt effectively less and less practical. This return to daytime shelter is not always an instantaneous or perfectly synchronized event, and some individual bats or owls may continue foraging opportunistically for a little while, even as the bulk of their fellow nocturnal hunters have already settled back into roost for the coming day. Researchers tracking bat colonies have found that individuals returning notably late, well after most of the colony has already settled, may sometimes face somewhat higher predation risk during this exposed daylight transition, a real, measurable cost to staying out and hunting a little longer than the rest of the group. Tonight's own long hunting hours are, in their own turn, eventually approaching this exact same familiar homeward return. One by one, tired wings and tired paws are already turning back toward whatever shelter held them yesterday. As dawn light strengthens further, honeybee colonies begin their own daily transition back toward full activity. Worker bees that spent the night clustered quietly together on the wax comb gradually rousing themselves, their drooping antennae lifting again as the whole hive's collective activity level climbs steadily upward toward the busy, purposeful daytime rhythm familiar from countless nature documentaries. The very first bees to leave the hive each morning typically function as scouts, heading out to assess weather conditions, temperature, and the general availability of flowers, before returning to communicate what they have found to the rest of the still gathering colony through their well-studied waggle dance. This careful, gradual morning transition from quiet overnight cluster to fully coordinated daytime foraging operation repeats itself with remarkable daily consistency across countless individual hives scattered throughout the warmer months of the year. Tonight's own quiet, clustered hives will, before very long, be following this exact same familiar morning sequence of their own. Researchers studying this early scouting behavior have found the information gathered and shared through dance can noticeably reshape where the entire colony chooses to concentrate its efforts that same day. We can leave those first few scouting bees to their work now and turn our attention toward the waking water. Fish resting quietly through the night hours, tucked into sheltered crevices or simply hovering still in open water, generally begin returning to their more familiar active daytime patterns as growing daylight penetrates down through the water column. Since increasing light levels tend to trigger both greater overall activity and, for many species, the beginning of active daytime foraging after the relatively quiet, low-activity overnight period. Predatory fish in particular often become noticeably more active around this specific dawn transition, since low early morning light can provide a genuinely useful hunting advantage, obscuring a predator's approach just enough while still offering sufficient visibility for the hunt itself to succeed reasonably often. This same dawn increase in overall fish activity is well known among anglers, many of whom deliberately favor these very early morning hours specifically, because so many species become measurably more active and, from a fishing perspective, correspondingly easier to catch right around this particular transitional time of day. Tonight's resting fish, tucked quietly among reef and riverbed alike, are drifting steadily toward this same familiar morning shift in activity. Down among the reef, one more shadow has already begun to move again, faster now than it moved an hour ago. Deer and several other crepuscular grazing animals, already introduced earlier tonight as creatures most active specifically around dawn and dusk rather than through the full stretch of night or day, begin their own second daily period of peak activity right around the same first light transition, emerging from the sheltered, thicker cover where they generally rest through the darkest, coldest hours to begin actively grazing once again in the strengthening early morning light. This particular window offers deer a genuinely useful balance of practical advantages: cooler temperatures than the coming full heat of daytime, reduced activity from at least some daytime predators who have not yet fully begun their own active hunting hours, and just enough available light to forage effectively and spot approaching danger from a reasonable distance. As this familiar dawn grazing period gets properly underway, the whole broader landscape is, in effect, completing one final full handoff between its various daytime, nighttime, and twilight active species, each one keeping faithfully to its own long-evolved schedule. Tonight's deer, still resting quietly in thick cover as darkness lingers, will soon be stepping back out into exactly this same familiar early light. Out at the tree line, one more shape steps quietly back into the open, right on schedule. Frigate birds and other long-distance seabirds, finally completing an especially long stretch of continuous ocean flight, generally show a clear, measurable increase in total sleep time once they do eventually return to solid land or a secure nesting colony, apparently making up at least some meaningful portion of the rest that their earlier, more limited airborne dozing simply could not fully provide across so many consecutive days aloft. Researchers tracking frigate birds with the same recording devices used to first document their remarkable in-flight sleep have found this land-based recovery period does not appear to fully compensate for every single hour of sleep theoretically lost during extended flight, suggesting the birds may simply function successfully with somewhat less total sleep overall compared to species that never face this same demanding airborne challenge in the first place. This resilience, tolerating what would be considered meaningfully reduced sleep in most other animals, without any obvious lasting harm, remains one of the more genuinely puzzling and actively researched aspects of frigate bird biology today. Tonight's own airborne travelers, still gliding somewhere over darkened ocean water, are steadily working their way toward exactly this same eventual, restorative return to land. We can leave that whole tired, homeward traveler to its long overdue rest now and turn toward the light itself. As true daylight finally spreads across an entire region, the rising sun itself provides the single most powerful and universally shared signal resetting each animal's internal circadian clock for the coming day. That same supraclasmatic nucleus mentioned back at the very start of tonight's journey, once again receiving fresh, direct information through the eyes about exactly when true daylight has properly begun. Melatonin levels, having risen steadily through the preceding hours of darkness, now fall away fairly rapidly in response to this same strengthening morning light, easing the gathering pull toward rest and gradually clearing the way for full daytime alertness to return across one waking body after another. This same fundamental daily reset, so quietly dependable that it rarely draws any real conscious attention at all, repeats itself with remarkable consistency across an almost unimaginable range of different animals, every single morning, on every single inhabited stretch of this turning planet. Tonight's long darkness is, even now, gradually giving way to exactly this same steady, universal signal, arriving as reliably as it always has. Behind 1,000 closed eyes at once, that same rising light is already doing its same quiet, dependable work. And so tonight's long, patient circuit through the sleeping and waking world finally draws toward its own quiet close, having carried us from soaring seabirds dozing on distant ocean winds, through owls and foxes moving carefully under starlight, down into dolphins circling slowly through dark water, past chimpanzees settled into nests woven only hours before, through the long, suspended stillness of hibernating bears and freezing wood frogs, and finally here, to this same familiar, dependable return of morning light that every one of these very different creatures has, in its own particular way, been quietly waiting for all along. What began as one single question, simply how animals actually sleep, has led us gently through an entire hidden world of half-closed brains, woven beds, locked tendons, and slowly rising melatonin. A world running steadily onward, mostly unnoticed, beneath the surface of every single ordinary night. There is nothing more this particular night needs from you now, except whatever rest you yourself might be settling toward as these last words fade. Whatever rest finds you now, some creature somewhere is very likely settling into exactly that same quiet stillness beside you. And so, gently, this long night comes to its own quiet close. We have traveled together from soaring birds dozing on the wind, through owls and foxes moving carefully beneath the stars, down into dark water where dolphins circle slowly, into nests built fresh each evening, through the long stillness of hibernation, and finally back around to this same first light that every sleeping creature we have met tonight has been quietly waiting for. Whatever rest you find yourself drifting toward now is exactly enough. Thank you for spending these unhurried hours here, inside the sleepy universe, among frigate birds and flamingos, dreaming octopuses and huddled meerkats, sleeping just as they always have, all around a turning world. If this journey brought you some measure of calm, consider staying a while longer and let sleep at its own pace finally take you. Good night. QC, chapters equals 10 facts equals 100 words equals 20,423.